Hello, everybody. Welcome to my little happy place. Let me make sure I've got the dashboard up. My name is Mark Mandel. Super nice to meet you all. I am a developer advocate for Google Cloud. Thank you so much to the Georgia Game Developers Association for joining me today. So, welcome to everyone from the Georgia Game Developers Association. Make sure I said my bit. If anyone wants to see upcoming streams, please join upcoming streams and other benefits of being a GGDA member. Check out ggda.org, which is on the screen right now. Thank you very much to them for promoting this and putting it forward and organizing a bunch of people who are interested in coming to see me talk about stuff. I have a cup of tea, and cups of tea are very important. Okay, so that's all fun. So a little about me. I work a lot in the infrastructure space. I do a lot of work on backend for specifically large-scale multiplayer games. And the conversation I want to have with you today is about why can't you just add more servers? Or the way I like to look at it is like, why is backend development for games tricky and hard? So we're going to start with a few slides and we'll get to talk about some topics, and we'll keep an eye on chat as well in case people have questions. If you're going to ask me questions, I would prefer the Twitch chat rather than the Discord, just because I've got the Twitch chat available in front of me and I don't have Discord up because I'll get notifications through my presentation and that would be sad. But we will make work do with the things we have. So I will give you a proviso. The beginning of this presentation is quiet, so if you're not hearing anything, nothing is wrong. That is just the way the beginning of the presentation starts. So let's get cracking. Okay, that was a bunch of negative emotions. So here's a picture of a dog wearing a party hat to make everyone feel a little better. Her name is Suki. She is adorable. But as you can see from here, right, there's a fairly common sentiment that this should be just a simple thing. Why can't you just add more servers? Players and sometimes even developers alike are just like, isn't this just a push button operation? Why can't you just suddenly scale out some more? But unfortunately, it's just not that simple to just add more servers. Just like anything in technology, and I think we've all probably hit this in one way or another in our lives, building software, building games, building just about anything. What seems simple from the outset, or whenever somebody uses the term just, it is never quite that simple. So I'm going to take you through a few different reasons about why you can't just add more servers, talk a little bit about some things that have happened with like backend operations and things that are particularly interesting and useful. And you'll get a bit of a perspective on why this is a little complicated, the sort of things that you need to look at and things you need to consider when doing backend systems for multiplayer games, especially. And we'll sort of step through and we'll have some fun. So I've got this broken down into stages. First thing I want to talk about is what I refer to as capacity planning. So what does capacity planning actually mean? So capacity planning is basically saying like how much load, how many players or how many people are we going to have at any given point in time? And how do we plan for that? How do we know what that is? And this is hard. This is the first problem you're always going to hit, and it's not an easy one. If you look at, say, maybe like a traditional web app, this is probably a little bit easier in that this is what like the load scale of a traditional web app, usually looks like. Not always, but usually looks like, where you probably have a fairly gradual curve increasing, and then it sort of, probably, flattens out after time. And I'm sure you probably have dips and troughs and that kind of stuff. And that's definitely a thing, and peaks and lows. But generally speaking, like it's a gradual increase up towards player load. And the other interesting part about this is usually it's towards the tail end is when you really start to make money. Right? So you've got your web app, you're starting to grow some users. As you get more users, you start to make some money, and you can incrementally change things about your system as your player base or your as the number of people who are using your web application continue to grow. And so you kind of have some time, and you have some period of testing and just making sure things go well and things go right. Now, let's look at games. Games are a little bit of a different beast. So this is what, a very typical load graph is for a game. And I think we've all seen this, whether or not you're building backends as a game, right? Or you're just doing, client-side game development, right? That big peak at the beginning of when you drop a game. There's, that's when the hype happens. That's when everyone's like, yeah, I want to play this game right now. That's awesome. And this is the scary part about games, right? Is just knowing how big that peak is going to be and how high it's going to go. Because for games, right, you're going to probably make your money sort of here, right? That initial hype, right? Like that initial huge bump. So you need to get that right, because you get that wrong, suddenly you're losing a lot of money. And then as we're seeing with games as well today, right, you've got these long tails. So probably also out there. And we're not really going to deal with like that sort of period where it's further out. But we're going to see it that, so just checking chat, that, really it's about that peak there. And like trying to predict the future is generally speaking not something that humans are very good at. I don't know if you've noticed that. So knowing how successful your game is going to be is really tricky. So often, I'll talk to people and they're like, well, it was a known IP, right? It's a known IP that's very well known. So shouldn't it just be successful? We know it's going to be successful. And like, what does successful mean? Is that 10,000 players? Is that 100,000 players? Is that 1 million players? Is that 10 million players? Each of those is a scale of difference that requires a much different backend system to be able to support that. This is not going to work so well over live stream, but the trick I like to pull sometimes is like I'll grab someone at the audience and say like, "Hey, what did you have for lunch today? Cool. You had a peanut butter and jelly sandwich. What did you have for lunch 3 days ago?" And they're like, "Oh, I had some chicken." And I'll be like, "Cool. So you know from history what you're going to have lunch 2 weeks time, right?" Which is again something that you hear quite regularly. People are like, "Oh, you can tell from past games what's going to happen." And sometimes, we're in a situation maybe like we're in now where like you're sitting at home and you eat peanut butter and jelly for sandwiches every day and you're like, I know what I'm going to have. But so often, right, you have really no idea 2 weeks from now what exactly is going to be happening and what you might be eating. So by the same token, you can guess what your players are going to do and how many you think you're going to have, but maybe you're just totally wrong. And that's a really hard thing to manage. So capacity planning is something you need to do and like something you should advocate for. And within your back-end systems and how you're going to plan for them, but it is a complicated thing and it is very hard to get right. It's a lot of guesswork. It's a whole lot of guesswork. So that's phase one, right? So that's where we first start. So the other side of capacity planning is you're like, okay, why don't we just assume that we'll get 100 million players and it's great, like that kind of stuff, is really the cost-benefit analysis. Anyone who's worked with technology, right? Everything has trade-offs. So when we start looking at more scalable solutions and things that are going to scale more as back-end systems go, or we commonly refer to these as distributed systems because they usually have multiple moving parts, the more scalable a system is, the more cost is going to be in there. So you're always going to be making this trade-off where you're like, okay, maybe if I build something really simple and I only have 100 players and I can start to make some money and that's great. But that may not scale to 100,000. That might not scale to 1 million. But then on the flip side, you might be like, oh, I'm going to build something that's going to handle 10 million players. But if I build a really complicated system to do that, then that's going to cost me a lot of money up front, a lot of time up front. I may not have that. I may not have that roadmap to go through. So that's going to make it really hard. Now, you can mitigate some of this by using pre-built services and that kind of stuff, which is great, and you should absolutely totally do it. But at the end of the day, it comes down to money. It's super important. You have to look at how much you can build and the complexity of the systems you can build, and that can be supported by what it is that you're able to provide. So there's always that really tricky trade-off that you're constantly making about cost-benefit analysis, about how scalable a system you're going to build, and how much money or how much time you're willing to invest to be able to support that kind of system. So let's get into some specifics of back-end systems, or what I like to call distributed systems, and the problems therein as well. So this one really comes down to my favorite thing, which is like everyone's like, why can't you just scale it out more? Like, why can't you just add more servers? And so we've talked a bit about like how capacity planning is hard and knowing exactly what you're going to do and like cost benefit analysis. But this is like one of these things that you really can't get away from when building backend systems or distributed systems, which is essentially what is referred to as bottlenecks, right? Which is the single part or possibly multiple parts within your system that you've built that everything has to go through. Because even if you do add more servers, right, that can still become a problem. So I'll give you a classic example. So let's say this is our pink area. Here's our black end infrastructure. We have a multitude of servers sitting here, and we want to store some data. So traditionally, right, you're like, cool, let's make a database happen. This seems easy so far, right? No problem. So we've got all our servers. They're talking to this database, which is awesome. So great. Thank you so much. But you might start to see what's happening here. So you're talking our database. Everything's fine. We pick up some players. They're sending some data through to individual servers, doing different things, sending back data to that particular database. We're like, cool. That's totally fine. No problem. And then we start to pick up more players, right? And this is where things start to go, right? We start to see slowdowns. We start to see, maybe some timeouts. Things start to go a little bit wrong in places. And we're like, what's going on? And we start looking at our database and we're like, oh, our database can't really handle the amount of load that's coming through it. So we're like, okay, cool. Maybe we can throw some extra servers at it. And there's a variety of patterns we can do to solve this, but we can scale out these servers out here. But databases as a whole, and it can depend on database, depending on what it is you're using and how you use it. But these can be much harder to scale out in a horizontal way so that you can spread the load across more machines. And this becomes one of the most quintessential bottlenecks within any sort of distributed system or backend system for games, right? We can add more servers, but at the end of the day, the data has to go somewhere. So what do we do? So here's an example. So if you're using something like a relational database, like something like MySQL or Postgres that many people are familiar with, you can do things like have a read replica. That's a pretty common pattern. So a read replica basically takes the data from that particular that particular database, usually known as like the primary. So this becomes like the secondary, and we can start to offload some of those read requests that we have to go to that read replica as we start to scale up. Now, what becomes fun here, you might not realize, is that there's always going to be a lag between what's in your primary master and what's in your read replica. And so you have to manage that at all times. So you might be like, oh, I'm a player. My player just won this match, and we're going to give them an awesome sword. And so we're going to store that in the primary database because rights have to go to the primary database. We don't have a choice there. And then we're like, awesome. And then let's show the player and say, player, let's look at our inventory. And suddenly the sword's not there. And our players are like, what's going on? That doesn't make any sense. But because there's that lag between, and usually that lag is what we call eventually consistent, right? We don't know exactly how long that lag is going to take at any point in time. That can make things tricky. We always have to manage that as well. So there are a multitude of different strategies that we can apply here. We can do things like read replicas. We can do things like sharding, so have multiple databases. So like, for example, like, you know how when you go in, you go up to, so you're registering at a conference or something, and they'll do like, A through E, F through N, right? Like, do that. You can do that across databases too, but that again becomes more complex and hard. Common thing I've seen happen a lot, which is this, right? Like, people end up in this scenario, they have a wonderful catastrophic success, and then suddenly they're sharding their databases at the same time as they're trying to support their players, which is like super, super hard. That is like a ridiculously complicated problem. So trying to like change like the wheels on a train while it's moving, right? That kind of problem. And so this is where, if you can set things up certainly in front where like it's easier to scale, that can be great. But if you don't necessarily have those skills, or you just, you're like, we didn't think we were going to get this kind of load, so we made something simple that made it, worked at the load that we thought we were going to have. That's great too. So some of this stuff can definitely be tricky. So this is like one of the potential types of bottlenecks. There are lots of different types of bottlenecks you can have inside your system. But this is like one of those things that definitely can trip you up. And this is, again, like why you can't just add more servers, because you have these bottlenecks inside your system. So moving on from there, this is one of my favorite topics in the whole wide world. Software fails. This is the reality of life. Software fails. You can always guarantee that at any given point in time, sometime, somewhere, your software is going to fail. I don't write perfect software. I don't know anyone else that's writes perfect software. Software is always going to fail. And to mitigate this, to make this worse, and this is particularly true of back-end systems, and I'm sure it's also true of the front end of game development, something I'm not particularly familiar with myself because I don't work in that area. But as many of you are aware, right, like you write your game and you've got this client, you're like, awesome, and everyone's good, and then you hand it out to your players and they try and play with it, and they're like, on my machine, it doesn't work. And you're like, man, and it like works on my machine, but it doesn't work on others. By the same token, with backend systems, you can use bots, you can use load testers, you can like artificially try and replicate what you think a real user experience of like 1 million players coming to play your game is going to be like. But nothing is like real players hitting your game. Nothing is like it at all. They're always going to find something interesting. They're always going to do something you're not aware of, or right, like you never even thought of. So having real players is really like the one thing that tests it. But I don't know if you've also noticed this, but it's really hard to QA 1 million players. There's not 1 million players for you to like actually like find as people other than like real players. So you might have, I don't know, depending on the studio you're in, 20 people, 10 people, 100 people who are in your QA farm. That's actually not a lot of load. So you definitely will want to still do load testing and do some artificial testing of your systems, but nothing beats the real thing. Nothing ever beats the real thing. The real thing is always amazing. Unintended consequences. So this is the cousin of software fails. I like to do, this is one of my things, right? There are always going to be systems in place that do things other than what you expected them to do. So this is a great story. There's actually a write-up on this. One of our reliability engineers at Google actually wrote this story about a game we helped some people build. A lot of it's anonymized. But this is how you can accidentally DDoS yourself with some very simple things that you think make perfect sense, but is such an easy thing to do. So let's look at a typical example. Right? We were talking about before, right? So we have these servers, we have these game clients. People are playing this game. It's awesome, and we're getting these regular messages back and forth from game clients to game server, and everything is fine, right? Like we've got a system that scales. We don't have too many bottlenecks in our system. We're able to handle the load we have. Now, something horrible happens, right? Let's say we have an outage. Yeah, something horrible happens, and no requests from any of those players can now reach our backend infrastructure. Right? That's bad in and of itself. That's cool. Maybe we worked out what it was. Maybe there was a fire in the data center. Those things actually happen. Maybe your data center got struck by lightning. Also something that actually happens. And suddenly you can't get any of those things. So you go in, you fix it, you put out the fire, you do all that sort of stuff, and you spin everything back up again. Now, you might have done something smart. You might have said to yourself, so on my game clients, what I'm going to do is say, okay, if my first request fails, I'm just going to tell it to retry after like 3 seconds or something, like a set default timeout. It's going to like retry. It makes sense, right? Outages happen, software fails. We were just talking about that, for example. That's totally a thing that happens. So we should prepare for that. We should prepare for failure. That seems like a smart thing to do. So let's put this retry stuff in place. So as soon as we open back up all our backend infrastructure, once everything is back to normal, suddenly we have every single client hitting us at just about the same time. Suddenly we have to handle a whole lot more load than we would do otherwise. And it's really hard for us to bring our system back up again, which is loads of fun. And this is something that has happened. Like a lot of people have done this. And so like, you're like, smart, I'll put in retries. Excellent. Okay, so this happens once. It takes you a lot longer to bring everything back up, because you kind of have two choices. You can either just kind of wait it out a bit and let some requests through and not others, and it becomes really complicated, or like scale up your system like greatly and then try and scale it back down to match the load, right? Once everyone's sort of going okay. That's fun too. So that's a whole thing. But let's say you get through that and you think to yourself, okay, all right. So what I'm going to do now is I'm going to implement what we commonly refer to as exponential backoff. You're like, I did some reading. I've done some cool stuff. So exponential backoff says, all right, sweet. We're going to send a request. If that doesn't work, we're going to wait a second. And if that doesn't work, we're going to wait 2. And if that doesn't work, we're going to wait 4. If that doesn't work, we're going to wait 16, et cetera, right? Up until usually some base limit of like a minute or something like that. And we're like, okay, that seems reasonable. So, now when we do it, it helps. But you will find exactly kind of the same thing as what you had before. These things tend to exponentially back off in sync. It just happens, or like in chunks. Chunks will end up in sync. So you still end up with these massive amounts of requests coming in at the same time. And you can still overload your systems. So you sit down one more time and you think to yourself, okay, unintended consequences have hit me twice. I thought retries was a good idea, so awesome, which it is. And then you're like, exponential backoff. Everyone does that. That seems like a great idea, so let's do that. Awesome. And then you come up with the ultimate solution of this, because you're like, I don't want to finally do this. And what you actually do is you add some jitter. All right, and this is the eventual solution you end up with. So jitter is basically a random amount that you can add or subtract to a certain thing. So here you're going to say, I'm going to send, I'm going to retry, still have retries. I'm still going to exponentially back off. But what I want to do is add, plus or minus 1 to 5 seconds, based on a random factor. So then when everything comes back up, we have what looks more like regular traffic, and it's much easier for us to spin things back up. So this is where, like, again, real people under circumstances you don't necessarily have control over or potentially even expect makes a big difference to how your system scales. Because we've definitely seen it where in a game launches, everything seems to be going well. They hit some sort of bottleneck, something like that, and whatchamacallit, and everything goes down. They're like, okay, we have to go down for maintenance for maybe like an hour or like a day, right? And get everything back up and running. And as soon as they turn everything back up, they just get slammed all over again. And that can make things really hard. So, putting systems in place where you can queue people, putting systems in place where you can randomize who's allowed in. I think a great example of this actually, and this, what the Dauntless team did when they were starting to scale up. I noticed that when they were doing it, you notice they had a queue of people, and sometimes that queue got massive. It was like 3 hours long, but you look at what they're doing there and you're like, okay, that means they have so much control over how many players they have in there playing a game at any one time, and they can just manage that at scale to be able to say, we have N number of players. That seems to be working great. Excellent. Let's like add a whole nother chunk to that. All right, that seems to be going okay. We've got some breakages over there. All right, let's fix that. And they were able to really grow their player base in a way that I thought was really clever, because it meant that they had a group of people playing that game that were able to play it, well and have a good experience, versus what I've seen in other games, which is like a lot of people who can't play the game, but have a sort of okay-ish experience that's sort of not great, and everyone just leaves, which is not ideal. So think about that when building backend systems. How do you mitigate that initial rush? How do you control it? That kind of stuff. It's super, super important, and can really make the difference between like a really good player experience and hopefully, like people move on, unfortunately, very, very quickly. Cool. All right. So let's actually talk about some other things, which is like technical limitations. So what if your problem actually is that you need to add more servers? Like sometimes that also happens. Like I'm not going to say that that isn't the only thing that happens. Like there's these other problems we were talking about, but sometimes you do. Sometimes you're like, you know what? It would be really great if I had another 10,000 game servers. That would be sweet. How do I do that? So let's talk about that. So there's really two sort of scenarios here. One is like you're running your own servers. This is something that a lot of people still do. Like they run their own bare metal, and you need to be able to add more machines. This can be hard. Adding a server to on-premises could be anything from a couple of days to several weeks to get it up and running. So if you sit down and think about it, I think there's the more obvious side, which is, hey, I need to buy this server, have it shipped to my place, install it, that kind of stuff, which I think, you could potentially, depending on your supplier chain and whether you have things available, that kind of stuff could take a few days for that machine to actually physically get to you. Then once the machine gets to you, you need to install all your firmware updates, make sure like your firmware is the same across all your machines, make sure hardware is working, run through a hardware test, make sure that's working appropriately. Maybe something in there isn't, so you need to return it. Get it installed in your rack, install all the systems that you need inside that machine, right? Like there are multiple steps that you need to go through to get that machine up and running that is not just as simple as going chunk and plugging it into a machine. So if you've got a player base that's like, hey, I really need more servers, and you need to physically put more machines in a place, that can be hard. And it's like super, super fun. I see an interesting question here. Where's a comment? We used to suffer packet loss from overtasked servers, and then when we added more servers, had more packet loss from bad connections with the new servers. Georgia Game Devs. Yes, exactly, right? Like suddenly you can have catastrophic success, right? That is a total thing that happens, right? So that's great. So yeah, so adding more physical servers definitely can be a problem if you're running bare metal. Bare metal has some advantages. Sometimes it can be a little cheaper to run than other things. Obviously, there's a lot of people I know who love bare metal because they feel like it's more performant for a variety of reasons, and it can be in some scenarios. So then let's look at the flip side, right? I work for a cloud company. Awesome. Can't you just move to the cloud? Isn't that like the whole idea of the cloud? Yes, that is totally a thing you can do. Cloud is more flexible, and you can do a lot more with it. But again, trade-offs. Different cost structures, different pricing. Depending on how things are architected, it could be cheaper or more expensive. Often bandwidth is more expensive in the cloud than it is on-prem, but it means that you can able to scale up and scale down or put together systems that you wouldn't necessarily on-prem, right? You could re-implement your entire production workload, your production like development system in a completely other environment for testing, which is much harder to do on-prem. So there's a variety of trade-offs that happen there. Obviously, I work for a cloud company as well. We love it when people run in the cloud, but you really do have to think about that. Now, a lot of people will mitigate that, all right, by running some stuff on-prem and some stuff in the cloud. And like what we refer to as usually bursting into the cloud is the lovely marketing speak for it. And that's great too. But again, more complicated, more systems. You don't have a homogeneous system. Like you have very different systems. That means you might have to do different things in different places. So again, like how much money do you want to spend on that? And the total cost of ownership of all of that system becomes complicated. And there is one other thing, right? Like the magical system of the cloud, at the end of the day is also just backed by machines. We don't really talk about it as cloud providers, but like there is an actual limit on the number of machines that we're able to give you at any given point in time. So if you are going to a cloud provider and you do want to expand out, make sure you talk to your sales team, get an account manager, talk to them about the capacity you want and the time frame you want it, especially at launch. This is super important. I've totally seen it where people have just assumed that, hey, it's a cloud provider, I can just order 10,000 more cores or like 100,000 more cores or like pick a number, right? Those numbers are not indicative of anything. I'm just pulling them out. And then, when it comes time to launch and they've just assumed they're going to have this capacity there, suddenly they don't. And they need to, because, the data center hasn't planned for it or the teams behind them haven't planned for it. And they're just, not going to assume that someone's going to have this massive spike of player traffic in a particular zone because that's just what they've done. And like there are real machines there. Like that's just the thing. So yeah, make sure you talk to your sales team, make sure you do capacity planning. Super, super important. Usually that's the way to really handle that kind of thing. I see a message. We have devs that like to control their own servers, but go to the cloud to handle peak or unexpected demand, especially on beta or launch. How do you plan for a hybrid situation like that? So that is a really good question, and it gets complicated. You can there are multiple ways you can handle this. Our Google Cloud, we have a bunch of stuff like Anthos, which is really like an enterprise solution for doing like a hybrid and on-prem systems. If you want to build your own, you can do that too, depending on how complicated you want to build stuff. I'm a big fan of the whole Kubernetes operating system for backend systems, just because it creates a homogeneous standard across the whole thing. So if you're not familiar with Kubernetes, it's an open source backend basically for running software over lots of machines. And so you could have, a Kubernetes cluster on your machines and inside that, and then a Kubernetes cluster on like Google Kubernetes Engine or on Azure or on AWS. And then you have a standard template for how you run your services across all of them. And that works super, super well. Even if you don't go down the full enterprise route, having a standard way of building apps across both what you have on-prem versus what you have in the cloud is a really nice way to do it. And it's become definitely a standard for a variety of platforms, from gaming to retail to media, etc., for how do I burst into the cloud. But that's a super good question. So, cool, fun. So that's a lot of good things. So I want to, I'm running quite early actually, which is good. So that means we have plenty of time for questions. But I want to finish on one note. So many people have probably heard the term ops before, or often referred to as like operations, or even they would have heard this necessarily as sysops. So like the management of systems, how like IT and backend infrastructure gets managed. That's probably something they've heard. If you work in backend systems or infrastructure, you definitely would have heard the term DevOps. If you haven't, that's also totally fine. So DevOps is a whole culture around how you build software and how to deploy it and the tools that are used to automate this and that kind of stuff. But I want to introduce you to one other thing. I want to introduce you to HugOps. HugOps is very important to me. So HugOps is about the idea of having empathy when operations management occurs. So at the beginning of this thing, I showed you a bunch of tweets and sort of negative feelings that people had when things aren't going their way as gamers or game developers are like, why am I not getting what I want? And here is, I think, just a much more positive bent on all of this, which is, software breaks. Things go wrong. That's just the reality of building software and making games, like software games, or games or software, I should say. So when things go wrong, let's be supportive of everyone, right? Let's send them positive messages. Let's send them wonderful things, because at the end of the day, right, we want people to make games. I'm sure we all love playing games. We all like making games. So let's create an environment where we, encourage each other to do these things. And, we're all working really hard to make things go right. No one's ever just been like, haha, I made a game and then, now it doesn't work. And like, now I'm happy about that. Like, that's not a thing. And no one's ever been like hugely motivated to, really get up in the morning and go and solve these problems by people screaming at them. That's just nothing. I don't know if maybe there are some people like that, but that definitely doesn't get me out of bed in the morning. What gets me out of bed is people who have been like, that's awesome. And like, hey, I know you're having a bad time right now, but like, it's going to get better. And I'm here for you when it's done. So that kind of wraps things up for me. Actually, I finished up a bit early. If that was interesting, I've got some, actually I don't write very often anymore, but you can follow me at compoundtheory.com is my blog. I do a lot of live stream development of some of the open source tools that I work on for backend, mainly around running dedicated game servers, which is honest.dev. You can see that. Everything I do goes up on youtube.com at that address as well. So you can definitely follow along to some of the stuff that I have and that I've done. Okay, I would definitely like to take some questions. Questions sound good. All right, I'm going to switch back to be there. It's much easier on my phone. Okay, question is, we've stress tested our own servers for load capacity. Excellent, but never done it for cloud servers. Is there anything special to keep in mind when testing cloud servers? Ooh, this is a really good question. All right, so the thing I like to talk about when talking about cloud servers is your priorities for testing will probably change. So I found that when doing load tests with like your own bare metal servers, you're usually optimizing for like CPU because you've paid for these machines and you're trying to get as many processes on them as many as possible, right? Which makes sense. When you move to the cloud, CPU tends to be a lot cheaper. What the most expensive part of things usually is actually bandwidth. So if you can spend more time optimizing your bandwidth throughput, you're going to actually get a much better saving on the cloud than you are if you're optimizing for CPU. So that's definitely something to keep in mind. Depending on what it is you're doing or who it is you're hosting with. I'm most familiar, obviously, with Google Cloud. So we have different tiers of network egress and that kind of thing. So you can also experiment with that. But yeah, I would definitely start with those kinds of things. Yeah, that's a great consideration. Focusing on bandwidth is not what I'm used to. Yeah, because you have to pay for your bandwidth when you're on a cloud provider. There can be some lovely benefits with that, but because you have some more flexibility about where you can put things, and it can be easier working in the cloud to meet players where they are without having to set up whole like colos or that kind of stuff. But you do have that extra cost that I was talking about, like moving into the cloud. The cost trade off there is different. Checking Discord real quick to see if I'm missing anything. Yep. Going back to packet loss. If you are optimizing for bandwidth, does that increase the risk of losing info? So I don't think so. So if you're optimizing for bandwidth, you don't want to obviously you don't want to lose info. That would be bad. Depending on what was I going to say? So really what you want to start looking at now. I am not a UDP communication specialist. I'm not like Glenn Fiedler or anything like that. But you want to start looking at if you've got your own UDP communication strategy, or if you're transferring data maybe over WebSockets or whatever it is that your communication medium is. If you can find clever ways to make that smaller, that's what's going to pay off for you. That's not necessarily saying that you should send less packets or anything like that, unless that makes sense for your game. That just means that you need to look at what your packet information is being sent and what is actually necessary to go across the wire, so that you can adjust that accordingly. So if there are things that when you're running on-prem, usually you aren't paying for the bandwidth. It just comes with like the bundle. So, you're like, I can send all this data and it doesn't necessarily matter as long as it's under, the service level objective, right? The amount of bandwidth that I'm allowed to send, between there. You might be like 200 kilobytes at any given point in time. That's fine. And I'm under that. So who cares? But if you could get that down to 100 or 50, right, then you can start making some real savings. So you shouldn't necessarily be looking at like packet loss. I don't think that's a concern. But if you can look at the data that you're sending and maybe there's stuff that's just not important, or if you can do some good mathematical operations to try and shrink that down, or look at a different serialization format or things like that, then that can definitely give you some good savings as well. We didn't go too deep on security considerations here. Is there anything special we need to consider for security and scaling up? Ooh, that's a good question. I would actually turn that around and say, make sure that security is built into what it is that you do from the start. Trying to slap security on at the end is bad. And especially when you have a hit game, because I don't know if you've noticed that people are horrible, but some people are horrible. So definitely think about security from the outset. So the things a lot of just standard best practices that you can take into account. I'm thinking about cloud stuff specifically, but usually when you're working with a system, you have some sort of IAM permission system. So who has accounts, what accounts do they have, what permissions they have, are they restricted as possible. Same things on your Linux boxes, right? All the standard stuff, don't run anything as root. Make sure everything's locked down in that way. At scale, that just becomes a bigger problem just because there's more people, and the more popular you get, the more of a target you might be, that kind of stuff. So where you might have just been it's a password on a post-it note that's sitting on my desk is fine, that no longer becomes fine. So just make sure that everything from your office all the way through is just standard, good security best practices. But that is a good question. I don't think anything changes. I don't think anything becomes particularly harder. You just become a target with more scrutiny, right? More people who are yeah, the thing. So try and think about that from the outset. What could potentially ever go wrong? Hire a security consultant. It's usually the best bet too. Yeah, security considerations at the end of dev always seem to be where the main problems explode. Yes, they do, and that's true of like so many things. I think, you work with anyone in gaming and they say, if I'm an audio person, get an audio person at the beginning. If you're doing animation, get an animation person at the beginning. Security is the same, like all that kind of stuff. Just start it at the beginning. You want to think about reliability. You want to think about all those kinds of things just from the start and make sure that's baked into everything you do. Because, once the train starts moving, it's super hard to put stuff on it as you go after the fact. So yeah, try and keep those things in mind. And then like that is also true of scale, right? If you can sit down and know where your trade-offs are and know that the decisions you've made were appropriate for the level you're at, you're like, okay, we've done this thing, right? We know it's probably going to be a bottleneck later on, but we have a plan in place. And if we have a wonderful success, these are the things we can do. It's much easier to be like, okay, now we can look at our plan and do the plan rather than being in a really stressful situation and try and come up with creative ideas on the fly, because you're going to have to do that anyway. So anything you can do up the front so that you understand how that's going, document stuff, write everything down, right? Like all that kind of stuff. Make those decisions, actual written knowledge that people can look at, as team members come and go, all that kind of good stuff as well, is always a positive. Whew. How soon do you anticipate having this video up on YouTube? At some point tomorrow. I have another thing that I need to put up, but I could do this first. I have a recording happening right now. I can make sure to come back on Discord and let people know when it goes live. Are you particularly excited to have this up? Sounds good. Much appreciated. Look forward to sharing it. Oh, that's so good. Thank you. Yeah, I'll put it on my YouTube channel. If people want to reshare from there. I'm usually pretty quick about getting my stuff up. My dog is about to bark. No, she didn't. Very surprising. I heard the doorbell buzz. Appreciate you being in Discord for questions. More of our devs are looking for multiplayer and need this. Excellent. There are some other resources, actually. I'll send you in a couple of places. I will, actually, let me pop over here. Yeah. So there's a couple of places that also, like a couple of really nice communities as well, that I hang out in that are pretty good. So there's Mastering Multiplayer that has a Slack. That is super nice. There's a community Slack channel where a bunch of people hang out in. Since I know you're all on Discord, the other one that I also hang out in, which is Gaming Bass, I want to say. Yes, this is the one. If you want to look for that one, I hang out on there. And there's actually, what's really nice about that one is they have channels for a variety of back-end service providers, everything from people who are trying to do stuff themselves, but also like ourselves in the programs we have, as well as people from Azure and like Excel Bytes and AWS's GameLift stuff and GameSparks and PlayFab and Photon and like all the different kind of groups. There's a really nice little community there that you can gather along with, which is super nice. So yeah, just look for online game dev baths. They've also got some documents around comparisons between servers and finding the right thing that fits for you based on like your team skills and the things that you have on your team and the operations knowledge you have. Especially in the indie space, some people have those skills and they're like, oh, okay, we can do a lot of stuff ourselves. A lot of other indies or even mid-sized studios don't have those skills, and so they're looking for back-end services that can do a lot of this stuff as well without them having to do as much like hands-on work. So all this stuff is possible. Oh, I was going to show the window for that. I just realized I didn't. Let me pop that up. This looks like the one I was looking for. Let me... throw this up on here. So here is Mastering Multiplayer, masteringmultiplayer.com. That is one of them. I found this website. Yeah, this looks like it. Online Game Dev Baz is the other one that's also super, super useful. So you can check both of those out. If you're looking for more information, I'll also hang out on Discord. More than happy to do so. But if you want to see more communities that are specifically dedicated to that kind of thing, both of these are super nice. Final messages. Cool. I see a number of GTDA devs on in the chat list. I hope you all found this valuable. Yes, I hope you did. All right. Yeah, great. I'm happy to hang out if there are more questions, but if not, yeah, thank you for hanging out with me. I hope you did find that useful. I hope that gave you some ideas about stuff that can be problems, but hopefully some mitigating solutions. But just understanding those trade-offs and understanding where those decisions lie, and so you can sort of walk in with like a clear idea about where some of the pitfalls can be. Hopefully that'll save you some problems going forward. Fantastic. Yeah. Thank you so much for say thank you, and look forward to having me back in Georgia. Yeah, I'd love to come back to Georgia. Atlanta is a special place in my heart. I have a lot of friends there. All right. Wonderful. Well, thank you so much for joining us. You can follow me here on Twitch at Mark Mandel. You can see me at Twitter at Neurotic, or you can see me on YouTube at Mark S. Mandel. All right. Thank you so much for hanging out with me today, and have a good evening wherever you are, or day, or morning, or lunch, whatever it is, and I'll see you all later.